Hello everyone and welcome back to our channel. In this video, I'm going to talk about what a jet engine is, its working principle, applications and why was it invented.
Okay, before we delve into jet engines, let's look into Newton's third law of motion. So the Newton's third law states that for every action, there is an equal and opposite reaction, which means that an action must be done in order to gain an equivalent reaction out of it. So how can such action or work be done? According to classical physics, we all know that there are three states of matter. Now let's consider some cases. For example, vehicles such as car or trucks can move on roads which is in solid state due to friction is caused during its movement. Also, while on water, the ship can only travel if it pushes the water backwards by rotating its fins. And if an engine that operates with gas as its working fluid, it should be able to push the gas in order to attain movement. This is what the Newton's third law implies. Secondly, there is another quantity called momentum, which means the time rate change in momentum is equal to the force acting on its particle. So what can be done in order to make this process operate more effectively? Now, the term called jetting comes into play. It means a rapid stream of gas or liquid can be passed out through a small opening, provided that the output received will be at higher velocity. Why should we consider velocity? Because we know the formula of momentum is mass into velocity, and also it is easier to increase the velocity rate than the mass of a body. Also, on reaching a certain limit, it is not possible to increase one's mass, as the amount of mass consumed will be directly proportional to its propulsional rate. But it is possible to observe a mass of a quantity at lower velocity, but the output that is to be gained will be of higher velocity. So the jetting process which can be done here improves the efficiency of its propulsion system. Therefore, the reactive engine that can convert energy-rich liquid fuel into a powerful force called thrust by jet propulsion is called jet engine. While looking into these jet engines, how do you think the scientists proposed these machines to be applicable for aircrafts? So, let's retrospect ourselves into history. First, the medium for the process was considered very important. So, the medium here is said to be air. If the propulsion system can efficiently jet the air, it will be able to gain a huge amount of momentum. The secondary entity is energy. We all know that coal was used as a fuel source from the Industrial Revolution. Also, using steam engines was not considered as they were too heavy. Therefore, internal combustion engines was used initially in aircraft propulsion systems. These engines could only drive the propeller to create a propulsion because the medium was air, and in order for these engines to attain movement, it had to push the air medium out of its system completely. After some time, it was found that these engines could not function properly at higher altitude, because at higher altitudes, these engines did not receive sufficient air for its operations on reaching a certain limit. Therefore, supercharger and turbocharger was introduced so that the engine could work at higher altitudes. But the IC engines also faced another limitation, as it was a discrete power source engine. For example, if we consider a 4-stroke engine, the power is obtained only at the 4th stroke. Now, if we look into the propeller, acceleration takes place only on the 4th stroke, but remains deaccelerated on the remaining 3 strokes, thereby creating a huge amount of wobbling on reaching a certain speed. Therefore, the propellers could not reach higher speed despite having a huge amount of power. So, a continuous combustion chamber was needed for the superchargers, while jetting it, a huge amount of momentum can be gained. That is why a jet engine was invented. This engine consists of a dynamic compressor, a continuous combustion chamber, and a gas turbine. Open cycle means the heat energy which is being sent out from the combustion chamber is not regained, as it is being sent out to the atmosphere through the exhaust. This cycle is used both on jet engine as well as the rocket engine, because only the mechanical energy which is being gained on the gas turbine through a rotating motion is taken and the heat energy is left outside. But in a closed cycle, the fuel is not injected. Instead, the heat energy is added directly into the combustion chamber through a resistive coil. Due to the heat, the compressed air expands and it is sent to the gas turbine to obtain the mechanical energy. Here, the exhaust which goes outside will be at higher temperatures. The nozzle in the exhaust will have a thermal energy regeneration system which will send the heat energy back to the combustion chamber, thereby making a continuous process. Now let's see how the jet engine works. Initially, the compressed air is needed to burn the fuel more effectively. This is the job of a compressor. On using the compressed air and expanding it increases the efficiency of the combustion chamber. So how will we start the engine? Initially, from the compressor, the compressed air is gained as an output. Then the fuel is injected after the compressed air enters into the combustor. Here, combustion takes place by burning the fuel. Now, the heated combustion products are supplied to the gas turbine, which in turn creates a mechanical energy. In jet engines, the gas turbine and the compressor are connected through a single shaft, such that the energy from the gas turbine is transferred back to the compressor, which indeed starts a cycle. The compressor sucks the air from the outside atmosphere, compresses it and pushes it towards the combustor. This phase, according to the thermodynamic principle, is called isentropic compression, which means that the entropy of the system does not change. Now, the combustion chamber, on receiving this pressurized compressed air, injects the fuel simultaneously and combustion happens. This phase is called isobaric combustion, as pressure of the fluid does not change, but other thermodynamic properties are subjected to change. Finally, a huge amount of heat energy is gained with higher velocity. This energy is allowed to spin on the gas turbine, which comes under the phase of isentropic expansion, where the entropy doesn't change again. Then the exhaust is sent outside via the nozzle. As the nozzle increases the velocity and the amount of mass remains the same as the velocity, thereby increasing the efficiency of jet engines during the jetting process. This complete cycle is called Brayton cycle. Every thermodynamic cycles are categorized into two types. They are of open cycle and closed cycle. The turbojet engine is a basic engine in which the gas is once expanded is pushed hard against the front of the engine. The turbojet sucks the air, compresses it and sends the compressed air to the turbine, thereby creating a rotating motion to spin the turbine. At last, the plane is pushed forward when these gases bounce back and travel to the rear of the engine's exhaust. Example, Lockheed SR-71 Blackbird. This aircraft is a long-range, high-altitude Mark III strategic reconnaissance aircraft developed and manufactured by the American aerospace company called Lockheed Corporation. It was operated by both the United States Air Force and NASA. SR-72 is under development and is set to fly on 2025. The turboprop jet engine is attached to a propeller which is driven by a shaft when the hot gases turn on the turbine at the back. These are used in transport aircrafts. On comparison with the turbojets, the turboprop has better efficiency at flight speeds below about 500 miles per hour. These days, the turboprop engines comprises of propellers with smaller diameter and large number of blades for efficient operation at higher flight speeds. Engines with such propellers are called propfans. Example, Airbus A400M Atlas. This is an European 4-engine turboprop military transport aircraft. It was designed by Airbus Military as a tactical airlifter with strategic capabilities to replace older transport aircraft such as the Transall C-160 and the Lockheed C-130 Hercules. Most of today's airliners are powered with turbofans. A turbofan has a large fan at the front through which it sucks the air in. The air flows mostly around the outside of the engine, thereby making it quieter and giving more thrust at low speeds. All the air enters into the intake process through a gas generator of the turbojet, whereas only a portion of air goes into the combustion chamber of a turbofan. The remaining air passes through a low pressure compressor and is directly ejected as cold jet or mixed with exhaust of gas generator to create hot jet. The main aim of this bypass system is to increase thrust without increase in fuel consumption, which is achieved by increasing the total airflow and reducing the velocity within the same total energy supply. Example, Sikorsky UH-60 Black Hawk helicopter. This is a 4-blade, twin-engine, medium-lift utility helicopter manufactured by Sikorsky Aircraft. Sikorsky submitted the S-70 design for the United States Army's Utility Tactical Transport Aircraft System competition in 1972. The turboshaft engines operate just like the turboprop engines, though it does not have a propeller but powers up the helicopter's rotor. This engine is designed with such specifications so that the helicopter's rotor is independent of the gas generator's rotating speed, which in turn keeps the rotor speed constant even though the generator speed is modulated according to the amount of power produced. Example, CH-53 Sea Stallion. The CH-53 Sea Stallion is a family of heavy lift transport helicopters designed and built by Sikorsky Aircraft. Originally developed for use by the United States Marine Corps, it is currently in service with Germany, Iran, Israel, and Mexico. The ramjets are the most simple jet engines with no moving parts. It is a turbojet in which a rotating machinery is omitted. Its application is restricted because its compression ratio on the whole depends on its forward speed. There is no static thrust developed and a very little thrust in general below the speed of sound. As a consequence, a ramjet vehicle requires some sort of an assisted takeoff, such as another aircraft. It has been used primarily in guided missile systems. Space vehicles also use this type of jet. Example, Black Hound Mark II. The Black Hound Mark II was a relatively advanced missile for its era, roughly comparable to the US's nuke Hercules in terms of range and performance, but using an advanced continuous wave, semi-active radar homing system offering excellent performance against electronic countermeasures and low altitude targets. And soon, the jet engine is to be combined with a rocket engine, which makes it an air-breathing rocket propulsion engine, which is said to be a future of spaceflight. There are different types of jet engines, which performs the same functions with diverse components that are different from one another. The jet engine have lots of applications in this modern world. It is used to power aeroplanes like Boeing 777, trains like UAC Turbo Train use a gas turbine engine, electrical generators, guided missiles such as BrahMos 2 use scramjet engine, which is a supersonic cruise missile, and tanks like YUM-1 use a gas turbine engine. It is also used in surveillance drones for the military missions. That's all for today's folks. In the upcoming videos, we'll be talking about the parts and the generation of jet engines. If you like this video, please like, share and subscribe to our channel, and also please leave your valuable comments below. Thank you.